that because we use what? Steel as the reference material. So this will be 70 divided by 200. So this is 7/2. Okay. Now, physically, what does it mean? Okay, when we select steel as the reference material, or when we select aluminum as the reference material, what are we changing? Okay, what are we changing in our analysis? Okay, so again, okay, our draw down here. Okay, so the original structure, okay, the original. So I'm going to sketch out the original structure. Okay, so we have it's a 4x8 square. Okay, so we know that right. So we know that this is our steel and this is our aluminum. Okay. Now, if we were to use E, okay, so if we pick the reference material as steel, right? What it means is, okay, if when we choose the steel, the reference material as steel, the aluminum section during the analysis will be replaced by steel. Okay, the aluminum section will be replaced by steel. So what does this mean? Okay, so the steel, right? Okay, the steel will still have the same geometry. The steel geometry will not change. Okay, the steel geometry is like still like this: 2, 4, 6. Okay, so this is the steel. Now, when we replace the aluminum with steel, and the structure must still have the same capacity to withhold stress. What do I mean by that? What I mean by that is when I replace the aluminum with steel, during the analysis, the structure cannot be more enhanced. Okay, so it has to be able to change or to withstand the same load. So when that is the case, the aluminum has to change by its geometry. So we calculated the N of aluminum is equal to 70/200. So now the aluminum has to change its size. Okay, and the geometry change is only in its width and not height. Okay, so i.e. height is held constant. Okay, so what do I mean by height? This geometry over here, this is my height, or depth. I call it depth. Sorry, I'm going to change this to depth. So the depth geometry cannot change. And I'll tell you why later. However, this geometry, the width, can change. Okay. So I'm just roughly going to sketch the width or the steel now replaced with it. So the width will change to like this. Okay. So this is now my steel section. So now we replace the whole thing. Okay, we replace the whole thing in steel. This is the geometry. So this is the aluminum section that has been replaced by steel. So if the original width is 1, 2, 3, 4, 5, 6, 7, 8, the new width is just, for example, this is just sketch 1, 2, 3, 4. The width is still the same. However, the depth got 4 boxes, 1, 2, 3, 4. The depth got 4 boxes, 1, 2, 3, 4. The depth thickness is one square. This is also 1 square. Okay. Now, can anyone tell me, you all understand what I mean, yes or no? Or you are not clear? Anyone not clear about this? So as I said, we replace the aluminum with steel. Okay. And the structure cannot be enhanced. Enhanced means cannot withstand more stress relative to the original. Okay. Now, the reason why the width is constant and sorry, the reason why the depth is constant, the width is fixed, is due to the second moment of area. Okay, so I want you to recap the second moment of area. Okay, so hold on. So remember, when we calculate, so if I were to draw our transformation over here, okay, this is the cross-sectional view. Right. So to find IZZ is equal to, so for non-sandwich material, we use IZZ is equal to width depth cube over 12 plus by width multiplied by depth multiplied by big Z small z squared. Oh, sorry, y, not z. Okay. Now, remember, for sandwich material, the rule is such that the thickness change and the depth is held constant. So now IZZ is equal to NW, right, which is the width. Then you have D cube over 12. So the depth cannot change. Okay. plus by NW, the width change, multiplied by depth y bar squared. Okay, and y bar and small y bar is a depth function over here. Okay, so we have to be careful. If you allow it to change, okay, so the wrong concept, okay, I highlight over here, the wrong concept is allow depth to change and width is held constant, right? We will have problem with our second moment of area, and let me elaborate. So now this is IZZ. So width is held constant. Now this is what? N depth cube over 12 plus by width is held constant, and then with a N depth, and then you need to compensate for your big Y bar N, or I don't know how to write this out, okay? So probably there's another compensator for the what? For the centroid, or for, okay, it has to be like that, okay? And there's a N over here, okay, squared. So the problem comes here, okay? You have a width. Now you cube your what? Your N value, E cube over what? 12. Okay, and this is wrong. Okay, this is just purely wrong. Okay, and make the analysis very complex. And then over here you have N D, okay, and then you have this term over here. So it make the analysis really complex. Okay, so this is wrong. So that is why, right, we have to deal in the sandwich material where we only compensate the what? We only shift the what? The width for this reason. It make determination of the second moment of area lot simpler. Okay. Now I will still do the same. So just to let you, so the first part of the example, I say the reference material is steel. Now what if now? Okay, what if now I'm going to draw the same. Okay. What if now right? So again, this is steel, and this is going to be what? Aluminum. What if now the reference material is what? It's aluminum. Okay, the reference material is aluminum. So N of steel, right, will become E of steel divided by E of aluminum. So this is 200 over 70, which is equal to 220. So it is 2.85 or 2.86, and N of aluminum is E of aluminum over E of aluminum because it represents, and this is equal to 1. So what does this mean? Okay, this means this. So the aluminum is still the same. Okay, the aluminum geometry is like that. Okay, this is our aluminum, still the same. Okay, our aluminum is still the same. Okay, so 2468 box 2468 squares. Okay, now the steel has to be 2.86 times.